Hi there, my name is Ron Rogers, and this presentation is titled, to help certify fly-by-wire aircraft in the high-intensity radiated field environment, HERF environment, we use a DC-3. Now, if you guys, my people who follow me for electrical engineering type of things, if you haven't all unsubscribed by now, I've got one for you. I know I've been negligent. I've been talking about flight tests and airplanes and being a captain and stuff like that. And you probably felt that I've let you down because, I haven't done anything for a while since the radar story and stuff like that. But this is for you. This is for you. Um, and here's the way it goes. Well, back in the late 80s, the Airbus uh, 320 and other aircraft were coming into the environment, and they were being flown. And people were getting concerned because these were fly-by-wire aircraft. And, like a lot of things, industry leads the certification authorities, and there wasn't really good standards on, well, how do you certify these aircraft? I mean, we'd had military fly-by-wire aircraft, but that's a very intense environment, and they had been certified to very high values. And it's, well, do we want to apply the same thing to commercial airliners? How are we going to handle this? So that was an issue that needed to be addressed. And the SIE Technical Committee AE4 handles electromagnetic compatibility. Okay, well, they decided to put together a kind of temporary committee, AE4R. And I had come back from recall. I had worked, the last thing I'd done is work for Boeing as an electrical engineer, and I was lead engineer in the microwave technology group. And I was asked as an ALPA volunteer, Airline Pilot Association volunteer, if I would sit in on some of these meetings. Okay, so I went to the meetings, and there were a lot of good people, very intelligent people at these meetings. This was quite interesting. Well, the person who chaired the main committee, AE4R, was a gentleman, a very senior program manager at Boeing up in Seattle, and I was in Wichita. But although we were, at different locations, we had known each other because we had worked together, and I knew some of the FAA people because we had worked on a few projects. And I'm kind of the odd man out here. All these people are engineers, and yeah, I'm an engineer, but my main thing is I'm an airline pilot, and I'm was brought into this or asked to be involved because of my aviation background. And I could bring some, real world, how do airplanes fly, and how close can we get to various emitters and stuff like that. So I was bringing in some kind of real world type of analysis to this whole thing. Well, it was kind of interesting when the two of them, one of the FAA guys, a boss, and the Boeing manager approached me and asked me if I would be chairman of one of the three subpanels, and the subpanel was data accuracy. And this panel was to determine what was the level of threat that the aircraft needed to be protected against. Well, I was a little bit surprised by that. I was just kind of there to, be part of the committee and watch what was going on. But I ended up being chairman of this committee. And these are a lot of the people that I had on my committee. I still had their business cards in a file, but there was a number more. This thing went on for 10 long years, let me tell you, and that's not even it goes on farther than that. But my involvement in it, I was chairman of this panel for 10 years, and we had meetings all over the place. And typically, how engineers work, we had a meeting, and then we'd have another meeting, and we'd rehash this. Then we'd get a few new people on, so we'd rehash this again. We'll go over, well, what is the threat? How close can you come to these emitters and stuff like that? Well, it was a fun bit of work. So, there are a lot of emitters out there, and a lot of them can be pretty darn nasty. And you kind of want to avoid it. And I'll talk about a couple of those in specifics. But one thing that the committee decided was, well, let's go out and do some measurements, because there's one type of emitter that we don't have a whole lot of data on. And that emitter is the over-the-horizon backscatter radar that uses 3 to 30 megahertz, which the Russians had these, and these were used in they've been developed actually since the 50s, but they were used mainly in the 80s. And I'm going to talk about the one we did. This is not it, because I actually don't have any pictures of it, but it was at Moscow, Maine, and it was our over-the-horizon backscatter radar. Now, they used around the ham bands. Now, the U.S. was nice. They didn't blast the ham bands. The Russians didn't care, and they would set their pulse radar right through the ham bands. And if you're a ham radio operator, you're very familiar with what we call the Russian woodpecker. Now, these antennas, because they're low frequency, kind of like some of the early World War II radar, the arrays are very large. And these arrays are large, they're very massive, and we decided to get some information on it, like I had mentioned. But the one I want to talk about is the Moscow main one, and it's kind of interesting. It went operational. I'm involved in this committee in the late 80s, and it became operational in 1990, but it was closed in 97 because, hey, the Soviet Union fell at the end of the Cold War, and it wasn't needed anymore. How's that working out for you, Ukraine? Yeah. Well, maybe that might have been a little premature, but they have other methods of doing this now, of seeing what the other side is doing. Let's put it that way. But anyway, what we did was Ohio University, and here it is. They had a DC-3, and this aircraft was equipped with test instrumentation that we could measure the field intensity in this frequency range as it was flown over. And they decided to set some points. And the main one they want to do is they wanted to fly over this at 500 feet because they figured that was as typically low as you could come to a structure, FAR wise. So we went out and we flew over this at 500 feet. Again, this isn't it. I don't have a picture. But see, I'm thought of as, I'm the committee chairman in that, and, organizational skills and stuff like that, and listening to these guys comment and talk about, well, how close could an aircraft come to various things. But we did this flight test, and the kind of the neat thing about it is I had a fun time talking with the pilot, and we're sitting down there with the group one time, and he asked me about my background, and he said, "Well, is ALPA, the Pilot Association, paying you this?" And I said, "Well, they pay for meals." And some of the other engineers said, "Well, who pays your salary?" And I said, "Well, nobody pays my salary. I mean, other than the airlines, this is a volunteer position." And that was kind of interesting. The engineers didn't actually realize that I was working for free. I told them, "Well, I make enough money as an airline pilot. I can do this on my side time, and I'm a volunteer, and I don't need to charge anybody." And I find this very interesting, and it's good for I said it's good for the organization, and the a pilot of N7AP interrupted me, says, "Well, you're doing it for the benefit of humanity." And I go, "Well, I don't quite look at it quite like that, but okay, whatever." It was kind of interesting because that airplane I talked about, N7AP, AP stands for autopilot. It was used by the FAA to certify the original autopilot on the DC-3. Yeah. Well, DC-3s have been around a long time, so that's how long this airplane had been around. But as you all know, you all are familiar with this equation, that commercial. 500 feet, given the size of this array and the frequency we're operating in, I mentioned to several of the engineers, I said, "Well, you guys are compensating for the fact that we're in the near field and the wavefront hasn't fully developed. So, we're getting questionable data as far as the true field intensity, and we're not really measuring what the established field would be at greater distances." Because I said, we're in the near field, and so we're not even in the Fresnel range. So they kind of looked at me and go, maybe this isn't just some dumb airline pilot. And they kind of scratched their head and says, "You're right. We got to take that into account." Well, like I mentioned, there are some really intense sources around the country, and that's just our country. Places where you don't want to be with an airplane. And this is Goldstone out in Southern California, very near Edwards when I flew, and they told us to stay away from it, even though we were flying, authorized to fly in the restricted areas. The way you take care of something that you don't want people to get near is you put it in a restricted area. And, well, Goldstone's in a restricted area, so commercial aircraft are not going to be penetrating this, because if the thing about Goldstone is they are a deep space network, and if you want to talk to a satellite that's way the far out there, Pioneer 1011, Voyager, things like that, you need a lot of power and you need a very focused, intense beam. This is not something you want to fly through with your aircraft. I mean, if you got steel cables, yeah, you're probably all right. But if you've got electronics that can be messed up, then you don't want it. And here's Buckley. They've got they're now Space Command in that, but they had some pretty intense emitters out there too, and you wanted to stay away from there. Well, as I mentioned, I was chairman of the AE4R Radiated Environment Data Accuracy Committee, and I put together a paper for SAE and presented it back in 1990. That's how long ago this was. And as part of our work, we established various field intensity levels, let's put it that way, that an aircraft could possibly be exposed to. And there's these are just the last couple of pages of the report that kind of talk about, what field intensity we felt it should be um, uh, checked to, tested to. Now, my understanding, and I worked on this for 10 years, and then I turned it over to somebody else, and they flailed with it for quite a few other years. My understanding was that they were going to have a FAR. It was going to be 1400 something that dealt with this. But what they do, like the FAA does a lot of time, they come out with an advisory circular. Said, well, you don't have to do it this way, but the kind of the thing is, if you know how the feds work, is if you don't follow the advisory circular, you've got to show us some other way that you have compliance, and generally that's not going to be easy. So, yeah, follow the AC, even though it's not mandatory. But if you don't, yeah, not so good. So the advisory circular, they took our graph that's not the easiest to work with, and they made it tabular, so it's easier to hand to a technician and say, hey, this frequency, this intensity level, depending on what you want to do, and that will allow you to test the aircraft and establish that they are safe. Well, this has been, right now over 30 years, and it has proved beneficial. Some of the initial field intensities were, we were being too careful. They were a little too intense. I'll admit now they were too intense. We were trying to err on the safe side, but some of the field intensities got so strong that you couldn't have anybody in the aircraft because the field intensities were too strong. So, yeah, you shouldn't be there anyway. But they've backed off a bit and made them more reasonable, and things have apparently worked out. We haven't had any events that I've been aware of due to electromagnetic interference. So that's a little bit of the history of the AE4R committee, if you're wondering. And if any of my strictly aviation people have stayed this long, God bless you. Anyway, thanks for watching.